Welcome. In the subject of transducer engineering, today we will be seeing some topics related to variable inductance and variable capacitance transducers. So in that, we will be especially concentrating on the principles of operation, construction details, characteristics, and applications of the LVDT. So before moving into LVDT, it comes under the type of induction potentiometer. So the variable induction transducer works generally upon the following three principles. One is change of self-inductance, and another one is change of mutual inductance and the production of eddy currents. So here we can see the self-inductance, the difference between the self-inductance, mutual inductance, and the production of eddy current arrangements. So here, when we are using aluminum and iron as the material for producing it. So moving on to your topic, linear variable integrated transducer, differential transducer. Here displacement will be a main theme. So displacement is a vector quantity representing the change in the position of your body or point with respect to a reference point. We will be taking a reference. Then we will be measuring the displacement, how much that by changing the position of your body. So it can be of linear or angular motion. With the displacement transducer, other quantities like not only the displacement, force, stress, pressure, velocity, and acceleration can also be measured and found. So in linear quantity, the magnitude of measurement may range from few microseconds to few centimeters. Okay. So simple type of displacement transducer is a variable inductance transducer. So very basic type is your variable inductance. So inductance is varied according to your displacement. When the displacement is changed, the inductance is changed. Achieved by varying mutual inductance between the two coils or by, so the change in inductance can be they achieved or the displacement can be measured by changing the inductance between either the self-inductance or mutual inductance between the coils. So the construction of LVDT, it will be consisting of two set of windings. One is primary winding and another one is secondary winding. In primary winding, there will be only one winding, that is called single primary winding, P1, whereas in secondary winding, it is divided into two halves. One is called S1 and another one is called S2. So there will be two secondary windings wound on a hollow cylindrical form. The secondaries have an equal number of turns. So the secondary is divided into two halves, right? S1 and S2. If there is four turns in S1, then S2 will also have 4 turns. So they will be having an equal number of turns, but connected in series opposition, so that the EMF induced in the coil oppose each other. The primary winding is connected to the AC source across a frequency range of 50 Hz to 20 kilohertz. So this is shows the construction of your LVDT. This is a hollow cylinder and the core is inserted inside the hollow cylinder, and this is your primary winding connected across your supply, and this is your secondary winding divided into equal but connected in a series opposition. So this is another, I have said either it is the movement can be of angular or linear, right? So this is another one. Here the primary winding, and here is your this is for angular movement, this is your linear movement. Here the secondary winding is divided into two halves and connected in series opposition, and the central core, based on the core displacement, the EMF induced will be changed and the displacement can be measured. So the movable soft iron core slides the hollow former. The position of the core determines the flux linkage between the AC excited primary winding and each of the two secondary windings. So when the position of your iron core changes, the flux linking between the primary winding and secondary winding will be determined. The core is generally made up of nickel iron alloy and reduced and slotted longitudinally. There will be slots in it to reduce your eddy current losses. The displacement to be measured is applied to the arm attached to the core. So with the core in the center, if the core is at the center, the induced EMF in the secondaries are equal So both the secondary winding will have a same induced EMF. As it is in opposing direction, the output voltage will be 0. Whereas you can see that when it is at null position, the output voltage is 0. When externally applied force moves your left hand position, more flux links to the left hand coil. So when you move your core to your left hand position, more flux will link to the left hand coil than the right hand coil. The EMF induced in the left hand coil will be larger than the right hand side. Hence, the magnitude of the output voltage is then equal to the difference between. So the output voltage will be difference between the voltage across the two secondary windings. When the core is moved to the right, more flux will be linked on the right side, and the resultant voltage is in phase with the right hand coil. So thus the LVDT voltage output voltage is function of your core position. Depending upon your core position, the output of voltage of the LVDT is varied. The amount of voltage change is either the winding is proportional to the amount of movement of the core. The output voltage is a function of distance of the core. Based on the displacement or the distance moved by the core, the output voltage varies. The polarity is indicated by the direction of the movement of your core. The amount of output voltage of an LVDT is linear function of the core displacement within limited range of motion. So the advantages of LVDT are linearity, high output, high sensitivity, ruggedness, less friction, low hysteresis, low power consumption, simple, small, and less weight. So it has many advantages than other types of transducers, as the hysteresis and friction losses are very low, and also it consumes very low power, and its sensitivity is high and output is high. So then it is a small in weight, right? So it can be less in weight, so it can be moved from one place to other place very easily. But the disadvantages are large displacements are necessary for appreciable. So based on the displacement, the output varies. So to get an exact output voltage, that displacement has to be large distance. So they are sensitive to stray magnetic field. As the inductive coils are used, it is sensitive to your magnetic fields. Dynamic response is limited by the mass of the core, and the temperature affects your transducer. Then application, as we all know, it is based on the displacement. So from a few micromillimeter to few centimeter can be measured using your LVDT. Acting on the secondary, it acts as a secondary transducer. It is used to measure force, pressure, and weight. The force and pressure is first converted to displacement, and with the help of your primary transducer and with the LVDT, you can measure it. So, thank you.